The focus of this video lesson is exponential automobile depreciation, part 2. Example 1. Leah and Josh bought a used car valued at $20,000. When this car was new, it was sold for $24,000. If the car depreciates exponentially at a rate of 8% per year, approximately how old is the car? So, similar to the previous lessons, we're going to begin with our exponential decay generic formula, which is y is equal to a times 1 minus r to the power of x, where a represents the starting value, r represents the depreciation rate, and x represents the time in years. So let's take a look at what information they give us. Well, they tell us the value when new, so that's our value for a. They also tell us the depreciation rate, and that's an 8%, so that's our r. But remember, when we plug it in its decimal form. So far, we know that y is equal to 24,000, 1 minus 0.08 to the power of x. Now, the question we're trying to answer here is at what time, in what year, right, was the car when Leah and Josh bought it. So basically, how many years after it was new, right, because they bought it used, did Leah and Josh buy it? Now, we know that when they purchased the car, it was in fact $20,000. So we're going to plug that in for our value, because remember, y is value. And everything else is going to stay the same. And what we're trying to discover here is what is x, the time in years. So let's go ahead and let's simplify inside the parentheses first. So our equation is 20,000 equals to 24,000. 1 minus 0.8 is a 0.92 to the power of x. Now remember, with solving equations, we reverse PEMDAS. So is there any addition or subtraction? No. Is there any multiplication or division? Yes. So let's get rid of the times 24,000. By dividing both sides of the equation by 24,000. On the left-hand side, we have 20,000 divided by 24,000, which is a 0.83 repeating. 0.83 is equal to our 0.92 to the power of x. Now, this is an exponential equation, so if you remember back to our previous lessons, the only way to get rid of an exponential is to do logarithms. So we're going to go ahead and take the log base 0.92 of both sides. So we have log base 0.92 of 0.83 and log base 0.92 of 0.92 to the power of x. And if we remember from before, the log base 0.92 and 0.92 to the power of x cancel each other, leaving us with just x on this right-hand side. And then on the left-hand side, let's go ahead and use Desmos. So let's get back into Google Chrome and Desmos. And we have here log base 0.92, and to do that base we use shift minus of, and let's look back, log base 0.92 of 0.83. Okay, good. Now do note, if you do not have access to Desmos, we can use a traditional calculator and just do our change of base. Remember, for log base 0.92 of 0.83, it's just log of 0.83 over log of 0.92. And you can type that into a traditional calculator and you notice that the values come out the same. So this is about 2.23 years. So we're going to say then that x is 2.23. Now remember, x represents our time in years. So we're going to say when Leah and Josh bought the car, it was about 2.23 years old. All right, now it's your turn to try. Try this. Laura bought a used car valued at $9,903.32. When this car was new, it sold for $21,000. If the car depreciates exponentially at a rate of 8 5/8% per year, approximately how old is the car? Now, note, to make this problem simpler, you're going to want to convert the 8 5/8 into a decimal form rather than fraction form. Give it a try.